I think now I'm recording, so for those of you who just can't get enough of me, you can go back and watch it later. All right. So we're going to cover probably a few sections today. We're going to try here 1.2, which is observational studies versus experiments. All right, I can tell you guys are my talkative class. Nobody ever says anything. Okay, so we're going to talk about several terms. Okay, so we're going to talk about a census. Now, you've probably heard of the census, but that's actually a statistical term. It means that you attempt to include the entire population in the sample. Okay? So sometimes that's great, such as when you're voting, you probably do want to do a census, but let me ask you this. If you were testing light bulbs, you wanted to see how long your light bulb lasted before it burned out, would it be a good idea to do a census? No, why not? What's that?
It would take too long.
It would take too long. Oh, that's one thing, but what else? Well, if you're testing every light bulb until it burns out, can you sell it? No, probably not a good idea, right? All right, so yeah, so sometimes you want to prefer a sampling method. So, all right, so let's see. So a census is a nice thing to do. Now we're going to talk about several different sampling techniques, and census will be one of them. Okay. So we're going to talk about observational studies. Okay. And the idea behind it is you observe and measure. You don't attempt to influence. Okay? So we're also going to talk about an experiment. Okay? With an experiment, you deliberately impose a treatment in order to observe a response. Okay? Now, some people prefer experiments over observational studies because one of the problems with observational studies is it can do a thing which is called confounding. Okay? Confounding means the effects of two or more variables are not separated. And I'm going to say due to another term that I want to point out here, lurking variables. Okay? And a lurking variable, my favorite definition is what you forgot to include in the study. But a better definition would be a variable not considered. Okay? Now, let's talk a little bit about these four terms here. Let's pretend for a moment that I didn't believe that smoking caused cancer. So the experiment says, okay, well, we're going to split the room down to half. You guys can't smoke. You guys have to smoke. Come back in 30 years, we'll see who gets cancer. Okay, so who wants to sign up for that experiment?
Depends on which side you're on.
Depends on which side you're on. If you're the non-smoker or if you're the smoker, you might want to be it, right? Okay. Would you think that would be ethical for me to impose smoking on half of you?
It pays enough.
If it pays enough. So they do pay people a little bit for some of these things, but yeah. So the idea is an experiment is, so a lot of people think experiments are the best ways to do a study, because I can say, oh, well, the only difference here between the non-smokers and the smokers is the cigarettes. Okay? But it's not really ethical for me to impose smoking on half of you, for example. Okay? So a lot of times, due to ethical reasons, we have to rely on observational studies. And in fact, smoking is a good example of that. All of the smoking studies have been observational. We've just said, okay, well, you self-selected, you're a smoker. We're going to compare you with a non-smoker. Okay? So, but the problem is it can cause confounding. Now let's talk a little bit about a study that was done back in the 1960s, I believe. And they did a study and they said, hey, we think that sugar causes heart disease. Now you've probably all heard that sugar causes cavities, but does sugar cause heart disease? Anybody ever heard that? Okay, so a second study did, and they said, no, sugar has nothing to do with heart disease. So you've got confounding going on, okay? Which study do you believe? Do you believe the first study? Do you believe the second study? Well, one of the problems with the first study was the lurking variable, okay? There was a variable that was not considered in the original study, okay? Sometimes these can be really weird, and this is, I think, a good example of a weird one. So what happened was the first study, one of the variables that they had not considered was whether a person smoked. Now, did you know that smokers consume more sugar? Who knew that? Okay, that wouldn't be something that would pop into your head. Why? Okay, well, back in the 60s, Starbucks didn't exist. Okay, they didn't have good coffee like they have now. Okay, so what would happen, a lot of people who smoked would get their black coffee. Okay, and how many of you drink black straight coffee? Really?
Yeah.
Isn't it nasty?
No, you just get used to it after.
You get used to it after a while. But most people think black coffee's nasty. That's why they go to Starbucks. Okay? And so smokers, a lot of times, smoking kind of deadens your taste buds. And so they would pour a lot of sugar in their coffee. More sugar than non-smokers, way more. So it turns out the difference between the two studies was due to the variable not considered of smoking. Because that wouldn't be something that you would normally think of, that smokers eat more sugar, or in this case, drink more sugar. They were drinking it in their coffee. And so that's why we had confounding going on, because they had not considered smoking. And so what turns out was, when the original study said it was sugar that was causing heart disease, it wasn't sugar, it was actually smoking. And it was covered up by the sugar, because they had not considered smoking as a variable. Okay, so this can be a problem with a lot of studies. Another case, you may have heard that vaccines cause autism, right? Do they or don't they?
No. We don't.
The jury's kind of still out, but there was actually, so the question is, well, one guy actually faked his data. Did you hear about that?
Yeah, I didn't hear about that.
Yeah, that was terrible. He was trying to show a link and it didn't exist.
Wait, who died and did what?
He faked his data to make it look like vaccines cause cancer, or cause autism. Yeah, so he was actually, that's a great way, that's called professional suicide right there. But actually, how about this one? Cell phones cause brain cancer. You guys heard that one? You don't hear that as much anymore, okay? Now, one of the problems is, and we haven't really been able to identify, but we've changed our cell phone technology. Now, let me ask you a question. Who knows what the technology is that gets the voice to your ear on the cell phone? Anybody know?
Electromagnets.
It's not electromagnetic.
Isn't it radio waves that go to?
It's not radio waves. It's actually microwaves, just like your oven. You know how these get hot? Those are microwaves, okay? Now, the problem is, do you remember the old brick phones? Anybody remember the brick phones? I actually got my fiance at the time a brick phone. It was a big old brick phone. That's not a brick phone. That's a little...
Close enough.
Yeah. It's an old phone, but it's not a brick, okay? Those old brick phones were analog, okay? And they had no shielding. Well, the first studies came out and says, hey, we think this causes cancer. What did the cell phone companies do? Well, not only did they switch to digital, okay, so they switched the technology, but they also decided, oh, well, you know, it would be really easy to put some insulation in there to protect your ear, okay? So the new phones have insulation that protects you from the microwaves, okay? So the question is, well, you've got a couple of lurking variables. You've got the analog versus digital. You've got the insulation versus the no insulation. We don't hear that anymore. Maybe they fixed the problem, but we don't really know. We've got confounding going on. Those are at least two variables that we can think of that could be happening. All right. Let's talk about some observational study types. Okay. All right. So we have cross-sectional studies. Okay. And the idea with a cross-sectional study is you collect info over a short period of time. A week, a month, maybe even a year, okay? So, the advantage is it's easy to collect and generally cheap, okay? The disadvantage, you can miss future, I'll say, stuff. And then I'll give you an example, okay? Let's say, for example, I wanted to find out the incidence of cancer in the room. And I walked around to everybody and I said, do you have cancer? And hopefully you all would say no, okay? So that would be an example. You know, I could do that in, what, 5 minutes? I could do a cross-sectional study. Do you have cancer? Hopefully the answer is no. Problem is, tomorrow you go to the doctor. Today you said, no, I don't have cancer, but you did. The doctor tells you tomorrow you did. Okay? So it's nice because it's easy to collect. It's generally pretty cheap. Disadvantage is you can miss stuff. You probably did have cancer. You just didn't know it yet. Okay? We also have what's called a case control study. Okay? And this is what we say is retrospective. Retrospective means you look back in time. Okay? So, it's often used in rare cancers. Okay? And you try to match people based on characteristics such as age, sex, etc. Okay? And the idea here is you say, okay, tell me your name. Connor, okay? We're going to pick on Connor for a minute. Okay, Connor, you've got cancer. Tell me your name. Russell, you do not have cancer, okay? You both come to Math 2040. Is it Math 2040 that's causing your cancer? Hopefully not, okay? But we're going to try to look at Connor and Russell and say, what's the difference between these two? They're both similar age, they're both male. Maybe one smokes, one doesn't smoke. Maybe one works at a nuclear power plant, one doesn't. You know, we're going to go and we're going to look at all these things and say, what's the difference to? So Connor would be the case, and Russell would be the control. Okay, so basically you try to identify and say, what's the difference between these two? Okay, so you can try to identify those. So you look back in time, you find out that Russell ate breakfast every day and Connor didn't, or Connor works on the graveyard shift. I was just listening the other day. One of the things that they said is a possible carcinogen is people who work the graveyard shift. Did you know that? People who work the graveyard shift are more likely to get cancer than people who don't. They think that has to do with something with disrupting your sleep cycles. So that can be an interesting thing. I guess the World Health Organization has said that's a probable carcinogen, is working the graveyard shift. So anybody in here with the graveyard shift? Oh, I'm sorry, you must be tired. Both of you? Before you have, but not currently, yeah. So, you know, you might not want to do that for long term. All right. So the advantage, well, I don't know. There's more. Well, the advantage is it's easier to collect. Not as easy as the case as the cross-sectional study. The disadvantage is you have to rely on memory. Okay? Especially if you're talking about diet and things like that, memory can be a lot of times people will say they're healthier eaters than they really are. Okay? Third thing that we have is what's called a cohort study. Okay? A cohort study is prospective, which means you look forward in time. Okay? And you follow people sometimes over decades. Okay? There's a famous study called the Framingham Physicians Study, still going on. It's been going on for about 40 years. They took a medical students about 40 years ago and said, okay, we're going to follow you over the next, for the rest of your life. Okay, so take a survey. One of my professors up at the University of Utah was in that study. He said every once in a while they'd send him stuff in the mail, like pills. And so they said, here, take this pill. He didn't know what it was. Hopefully it wasn't poison, but he would take it. And so one of the things that they found with this cohort study was some of them were given placebos, some of them were given real drugs. In his case, the real drug was aspirin. He knew because one time when he swallowed it, he didn't get the water fast enough, it kind of dissolved, and he goes, kind of tastes like aspirin. One of the things that they found was that the physicians who took aspirin had fewer heart attacks than the physicians who did not. Okay? So the advantage is better data collection. Okay, unlike the case control study, you're not relying on memory, you're following people over time, so you're going to get better data collection. The disadvantage is it's expensive and it can take a long time. Okay? All right. So that's the end of 1.2. we're going to move on to 1.3. There we go. 1.3, which is about simple random samples. Okay? So the idea with a simple random sample, everyone has an equal chance to be selected. This helps cut down on bias. Okay? Now, bias, I should explain, is to systematically favor certain outcomes. Okay? So a lot of times bias is unintentional. Okay? If I were to go to the mall, well, I don't know if this is true anymore, but if I were to go to the mall, who shops at the mall?
Teenage girls.
Usually young teenage girls and old people, mall walkers, right? So especially, we're going to miss all of you because you're in class, right? All the working people, okay? So if I were to do a survey at the mall, I'm going to systematically favor the young teenagers and the old folks, right? Because that's who's going to be there. We're going to miss all the working people. It's not that I intentionally chose those, it's just that's who shops there. A lot of times that's unintentional, okay? So the idea is if you can do a simple random sample, hopefully you will pick everybody, or everybody has an equal chance to be picked, okay? We've also got convenience samples. And just like that is, they are easy to reach. Okay. We've also got a voluntary response sample. And you can think of these as websites or call-in shows. Think of American Idol. Okay, that's probably one of the best things. I still say David Archuleta got cheated. Utah has a smaller population than Missouri. The problem is people with strong opinions participate more. Okay? And so you get, especially if you want to get a nice, good controversial topic like gun control or abortion, you're going to get some really people that are passionate about that. You might not get other people opinions. So that's another way to cause bias. Convenience sample can cause bias as well, just because they're easy to reach. So another thing we can do to alleviate that is to create a sampling frame, which is a list of all individuals in your population. Okay? So in a minute, we're going to do a poll in here. But what I'd like to do for our sampling frame, okay, is I'd like everybody to count from 1 to 22 or whatever we got here. And I want you to remember your number. So we'll start with you. What number are you? 1. Remember your number.
2, 3, 4,
5,
6, 7,
8, 9, 10, 11,
12,
13, 14,
15,
17,
18,
19, 20.
21.
21. Okay, so we've got 21 people. So what I've done is I've just identified my sampling frame. We're going to say that this class is the population, okay? And then I'm going to ask a nice, good, controversial question in a minute. Okay, so remember that. We're going to use that in just a minute, okay? We're moving on to 1.4 already, if you can believe we're just flying, okay? And we're going to talk about other sampling methods, okay? Okay, so other sampling methods are what we call a stratified sample. Now your quiz tomorrow, we're going to ask you to identify all these different sampling methods. And I know stratified sample, but the idea here is you divide into groups, also called strata, and then take simple random sample within the strata. Okay? Now, that's typically what happens in polls, okay? So for example, in a good poll, the idea here is you're going to break your group into men and women, Republicans and Democrats, blacks, whites, Latinos, Asians, that sort of a thing, high income, low income, middle income, okay? So those are the different types of groups. And then within that group, you're going to do a random sample. So we'll do an example of that in a minute. Another type of sample is called systematic. Okay, a systematic sample. You select every case individual, okay? So you can think of this as a nice simple random or a pseudo-random sample, okay? Where you select every third individual, every fourth individual, or whatever you want to pick, okay? So this is kind of you can think of it as a pseudo-random, okay? Randomization can actually be very difficult, okay? We'll also do what's called a cluster sample, okay? Now, a lot of times people get cluster and stratified mixed up, but a cluster sample is to select every individual in a cluster.
What does that say under stratified sample? Take what within the strata?
Every stratified sample, divide into groups or strata, take a simple random sample within the strata. SRS, simple random sample. Sorry, I abbreviated that. Okay, so an example of a cluster sample. Okay, what will happen is, let's say that the university wanted to do a survey of math students. Okay, well, rather than talk to every math student at UVU, they break into cluster and they say, okay, we're going to talk to all of the math 2040 students. Okay, we'll ignore all the college algebra students, but what we'll do is they would come into here, this class would be a cluster, and then they would talk to everybody in the class, they would do a survey. So that's a cluster sample. Whereas a stratified sample, you're going to divide it up based on some characteristic. Males versus females, Republicans versus Democrats, something like that. High income, middle income, low income. And then within those, you'll talk to 33% high income, 33% middle income, 33% poor, or something like that, okay? And you'll do a simple, you'll stratify after that. Okay, does that make sense? We'll do multistage sampling, which is a combination of methods. Okay, so what I'd like to do is I'd like to ask a good controversial question. Oh, here's what we'll do. So this is going to be on the ballot this fall. Do you support legalization of medical marijuana? Okay, that's actually going to be on the ballot this fall. Okay, so here's what I'd like to do is I'd like to do a survey here within the class, and I would like to ask you guys this. We're going to do a bunch of different oh, they changed it. Okay, that's coming on here. Okay, so what I'd like to, so we've got our sampling frame. So what I'd like to do is I'd like to start with a simple random sample here. Okay, now we're going to try to do groups of 4. I think we'll have one group of 5. Okay, so here's what we're going to do. You're going to be a group of 4. This front row is going to be a group of 5. This is going to be a group of 4. You'll be a group of 4, and the last row will be a group of 4. So 1, 4, 5. We're going to have 5 groups in here. We're going to do a sample, okay? And the question we're going to ask: do you support legalization of medical marijuana? And what we're going to do is, I'm hopefully going to share my thing here in just a minute. Tables. All right. Let's see if I can share this. Screen share. Okay, here we go. All right. So in the back of your book, and by the way, if you don't have a book, I've posted this up in the announcements. Okay, so you guys are going to be group 1. You guys are going to be group 2, group 3, group 4, group 5. Okay? So whatever group number I want you to use the same row number. Okay? We're going to do a very quick, oh geez, we only got 5 minutes left. We're going to do a very quick, simple random sample. You're going to talk to 4 people. Okay? And you're going to ask them that question. Now here's how it works. We've got, was it 21? Yeah. 21 people here today. So the highest number we can go up to, we're going to use it. 21 is a 2-digit number. So we're going to go every 2 digits. Now, let's say I'm on row 20 here. Okay? I'm going to go the first 2 digits. 67, there's no 67. I'll skip it. 41, there's no 41. 15, who's number 15? You're 15. Do you support medical marijuana? Yep. Okay, so yes. Okay. So what I want you to do is I want you to keep going. So we got 15, 85, you'll skip 42, 18, who's number 18? Okay, we'll ask that person, etc., etc. I want you to talk to only 4 people because we don't have a lot of time. They don't have to be in your group. Just say, who's number 18? And then I'll ask them, and then we'll do it. And so we're going to compile this. We're going to do a census while we're doing our simple random sample, okay? And then we're going to do a stratified sample, but you've only got like 1 minute to do this, okay? So very quickly, row 1, group 1, group 2, group 3, 4, 5. So I'll give you about 1 minute to do this. So move around, talk, it's okay. It's in the back of your book. Yeah. If you have to go on to the next row, that's fine.
We need number 9.
Who's number 19?
Yeah, who's number 19?
Who's number 12?
Who's number 9? Who's number 9? 12? 11? Who's number 9? 12? Number 9?
Yeah.
11. 64, 68, 45, 28, 32, 94, 64, 60, 88, 94, 40,
Who's number 2?
82, 64, 0.
Who's number 8?
38, 44 out of numbers.
Number 11?
Yes. 61, 45, 17, 60.
You guys need to answer each other. Who's number 11?
10.
You're 11. Answer who wants to know.
No.
21. Who's 21?
Number 2.
21 right here.
Who's 21? You are? Oh, okay.
He's number 2.
13.
2 is over there.
Yes.
Okay, this is a homework question. I'm going to give you a bunch of random numbers, and I hope you can figure out who to talk to.
14.
I'm number 18.
Who's number 14?
Yes.
Okay, we took too long. All right, well, I'm going to take your results right now, hopefully, I hope. Okay, group 1.
I am. Yeah, here.
Okay, group 1, how many people did you talk to?
4.
Talked to 4 people, how many yeses? 3 yeses, 1 no. Group 2, how many people did you talk to? 3. How many yeses?
1 yes.
1 yes, 2 no's?
Yeah.
Group 3, how many did you talk to? Or how many yeses?
3 yes.
3 yeses,
No.
1 no. Group 4,
I got 1 yes.
1 yes,
3 no's.
3 no's. Group 5,
3 yeses.
3 yeses, and 1 no. We almost got them there. Okay, so the census of the class, we're going to pretend this is a census. I think we're missing one. Was 11, well, actually, 11 yeses. Okay, so this is going to be equals 11 divided by the sum of this. Okay. Actually, we could do a quick census. So we've got 57. Okay, I'm going to just ask you really quickly. Yes or no?
Yes.
We have 1 yes, 2 yeses,
Yes.
3,
No.
3,
Yes.
4,
No.
4,
Yes.
5,
Yes.
6,
No.
6,
Yes.
7,
No.
7,
No.
7,
No.
7,
Yes.
8, 9,
Yes.
10,
Yes.
11,
Yes.
12. Okay, so the census, I just went around the room and I did the census, equals 12 out of 21. Okay. Oh, wow. How about that? Well, our overall randomization thing, so the correct answer was 57%. So if I take the yeses divided by the sum of both of those, okay, group 1, you were biased, you were too high. Group 2, you were biased, you were too low. Group 3, biased, too high. Group 4, biased, too low. Now, the problem is our sample size sucks, okay? Now, the idea here is, since we're out of time, I could have done a convenient sample. I could have had you 4 ask yourself. I could have had you ask yourself. That would have been very convenient, okay? I could have done a stratified. I could have said, okay, we've got half women, half men. We're going to ask half women, half men to see how that works, okay? So anyway, those are the different types of sampling distributions that we have. Quiz tomorrow will be on sections 1.2 through 1.4. We'll see you all tomorrow.